Class, we're starting 5.5, Inequalities Involving Absolute Value. Learning target AV3 says I can solve absolute value inequalities. So, if we could just kind of start off with, I guess, a little bit of a riddle. I'm thinking of a number that is less than 7 units away from 4. That's the only clue. What is the range of numbers I'm thinking of? Show the solutions on a given number line. Now, if it's 7 units away from 4, okay, so here is 4. Now, 7 units, it could be anything, right? Less than 7 units away. So that means I want to make sure I'm 7 numbers less than that, going this way, or it could even mean 7 numbers going the opposite way, but I want to make sure it's any number less than 7. So let me fill out number line here. So here's my number line. Again, I want to start from this number here, 4. It is a number that is less than 7 units away from 4. So what that means is that it can be any number. So from 4, the farthest away I can go is -3, and it can't be -3 because that is 7 numbers away. So it's got to be less than that. Or 11, I can't go farther than 11. However, it could be any number in between these two numbers. So my number x can be between -3, as little as -3, has to be bigger than that though, or 11. So that's kind of the range of numbers. So what we're trying to do today is we're giving a range of numbers now. That's what these less than and greater thans will do. Just as a little side note, if you remember, less than and greater than were excluded the number, right? And so that means that the number that we're talking about is not included. However, less than or equal to or greater than or equal to includes that number. So just kind of keeping that in mind, just as a reminder as we're doing these things. So let's just kind of go to our example. It says, write the following absolute value inequality as a complete sentence. Then show the solutions on the given number line. So again, absolute value is the distance. And so this is saying the distance between a number and -7. And the reason why it's -7 is because distance is subtraction often, right? So the distance between a number and -7 is more than 10 spaces. So more than 10 spaces. So if I'm looking at this number line here, the distance between some number and -7, so here's my -7, is more than 10 spaces. So if I were to fill out this number line, I know this number line is a little bit awkward just because I'm going up by 3s, but it's because my number line was limited. But if the distance between some number and -7 is more than 10 spaces, so 10 spaces more than -7 is at 3, so this is 10 spaces this way, and also 10 spaces this way, whoops. 10 spaces going in the negative direction, so that's right here at -17, and over here on the positive side at 3. Now, if the distance between this number and -7 is more than that, that means all the stuff in between can't be included, and since it has to be strictly greater than, what that means is it is any number on the number line that's bigger than that 3, and any number on this number line that's less than that -17. So if I were to write that as an inequality, I can't really combine these two statements, so I have to just say separate statements. My x number, my mystery number, has to be less than, not -16, but -17. It has to be less than -17, or it has to be strictly greater than 3. So looking at the number line, that's how we do it, right? Now, if we were to evaluate this, what actually happens, what I can do mathematically is take my absolute value of x plus 7 is greater than 10. What I can do is I essentially have two different problems, right? That's kind of what my conclusion is here. I know this is going to be one solution and x greater than 3 is going to be another set of solutions. So what that means is I have a possibility of x plus 7 can be greater than the 10 in the positive direction, or this expression x plus 7 can be less than my negative 10 spaces. And so as a process, you're kind of flipping the sign as you flip the positive to a negative. And then if you subtract 7 on both sides, you get x is greater than 3, just like how we have, or on the negative side, x is less than negative 17. So those are my two sets of solutions. I'm going to go through some examples on the next page. If you kind of need to watch that again, the number line part, or even the way I did it algebraically, you might want to pause the video and rewind. Otherwise, I'm going to move on. I'm going to kind of help organize your thoughts. If you have less than or equal to an absolute value like that, one thing to note is that your range of numbers is going to be in between two numbers. So if you imagine that number line again, what I mean is my range of mystery numbers is going to be between any numbers between two sets of numbers. Okay. Whereas if I have an absolute value that's greater than or equal to, then my range of numbers on a number line is going to be going the opposite directions. It's not in between these two numbers. So let's look at number 1. I have the absolute value of n plus 2 is less than 11. So if I want to do this algebraically, just with the process, then what that is going to look like is I have my regular m plus 2, which is going to be less than 11. I have my normal version, and then my m plus 2 is also going to be greater than the negative 11. I'm flipping the sign, flipping the inequality sign, as well as flipping the negative. And then so I'm subtracting 2 on both sides, and m is less than 9, or minus 2, m is greater than negative 13. And so if you were to imagine a number line, I just found that m can be anything less than this 9 and anything bigger than this negative 13. So it is a range of numbers in between. Okay, so again, if you were to think about the original statement, I'm thinking of a number. The distance between a number and negative 2 is less than 11. So I just want to make sure my range is in between these two numbers. Try examples 2 and 3 on your own using the algebraic method. Pause the video, try it yourself, and then when you press play, I'll show the work and the solutions. Here's the work and the solutions. Take a look, observe numbers 2 and 3 on my end. Again, algebraically, one of the inequalities is going to be normal, the way it looks already, and then the other one, n minus 8, is less than negative 2, so I'm flipping the inequality sign as well as flipping the positive to a negative. And then I'm kind of displaying it on a number line to show all the possible solutions, my range of numbers that I'm thinking of. If you need to rewind to any point of the video, pause, rewind, and do that, I'm going to move on to the next part. The next part, looking at what looks normal but is actually a unique sentence. It says, the distance of a number and 10 is more than negative 2 spaces. Now that's weird. This little phrase right here is a little weird. The distance of a number and 10 is more than negative 2 spaces. Well, let's look at that as an absolute value. So here it is as an absolute value. The absolute value of x minus 10 is greater than negative 2. Well, this is a statement that's always going to be true. Meaning, so here, let's imagine a number line. So I have my number 10 here, and I have this mystery number, the distance between some number and 10 is more than negative 2 spaces. Well, negative 2 spaces doesn't even exist. Any number of spaces is bigger than negative 2 spaces. So all of these numbers here on the right side of the 10 and all of these numbers on the left side of the 10 is more spaces than negative 2 spaces. So if it's an infinite amount, what that means is this is always true, right? And so what that means is my mystery number can be any real number, all real numbers. Right? And yeah, that's kind of what it's saying. On the flip side now, on B, for part B, it says the distance of a number and 10 is less than negative 2 spaces. Less than negative, again, that weird negative 2 spaces. Let me write that as an absolute value. Okay, the absolute value of x minus 10 is less than negative 2. How can I have less than negative 2 spaces? Maybe a number line will make more sense. Okay, so here's my 10. I'm thinking of a number. The distance between this number and 10 is less than negative 2 spaces. Well, 0 spaces is 10. Negative 2 spaces doesn't even exist. So that's nothing. There's like, this is not even possible. So there's like no solutions for this x value. And the symbol for no solutions is that. So that just doesn't make sense. So the lesson here is, like, if you have an absolute value that's greater than a negative number, yeah, that's all the numbers in the world. Or on the flip side, if an absolute value is less than negative 2, that doesn't exist. There is no existence of that. So let's try and solve and graph. Let's do number 1 together. I want to make sure, before I get started, I do want to make sure that each of these absolute values are isolated before I kind of do any kind of splitting. So I have the absolute value of x plus 5 is less than or equal to negative 4. Again, if I were to translate this says the distance between x and negative 5 is less than or equal to negative 4 spaces. Negative 4 spaces does not even exist. To go less than negative 4 spaces does not exist. So this is no solutions. There's no x value that can satisfy that. Try numbers 2 and 3 on your own. Pause the video, and then I will show the solutions that I have, and I'll explain a little bit more if I need to. Here's the rest of numbers 2 and 3. Number 2, I do want to make a couple of notes. First thing is, you can't, again, just as a reminder, you can't distribute a number outside of the absolute value into it. It doesn't really work like a parentheses, so if you want to get rid of that negative 2, you got to cancel it. So the only way to cancel it is to divide by negative 2. Now, when you divide, hopefully we remember this unique thing where when you divide by a negative, you have to switch the signs, right? And so that's what I did there. I divided by a negative 2 on both sides, and so that less than now flipped to a greater than. And then I kind of rewrote it just to talk about distance again. The distance between a number and negative 3 is more than negative 4 spaces. Well, so here's my negative 3 on the number line. The distance between any number and negative 3 is more than negative 4 spaces positively and even negatively. So this is all real numbers, all the real numbers in the world that I know. Number 3, again, I got to isolate the absolute value. I got to add 20 on both sides, divide by the 3. I end up with this funky fraction. That's all right. We love fractions. And then since I do have the absolute value isolated and I have a positive number on the other side, I'm good to go. So then I'm going to take my normal inequality, x minus 2 is greater than 31 thirds, or I'm going to flip it and x minus 2 is less than negative 31 thirds. Then I'm going to solve for x, and I get x is greater than 37 thirds, which is the same thing as, oh, I'm sorry, it is not 32 and 1/3, but it is 12 and 1/3. So anything greater than 12 and 1/3, or anything less than negative 8 and 1/3. Take a moment, pause the video, soak it all in, whatever you need to do, and then I'm going to move on to our final problem. The problem reads, a recent survey showed that 65% of young adults, that's me, watched online video clips, and that is me. The margin of error was within 3 percentage points. Find the range of young adults who use video sharing sites. Now, I'm going to show you this two ways. One way is I want to do it by a number line. So a recent survey showed that 65%, there's my 65 on a number line, of young adults watched online video clips. It says the margin of error was within 3 percentage points. So anything within 3%, so that's like up to 68%, so that's 3%. And then also 1, 2, 3, 3% going this way, right? So anything within 3% of 65 was the margin of error. So what that means is my the number of young adults, X, I'll say, can be between 62% or 68%. Okay. Now, if I were to ask you to do this algebraically, let's wipe this clean. If I were to ask you to do it algebraically, what you would show is that the difference. So I'm sorry. The survey, the absolute value of some number, and 65, which is the number of young adults, and the margin of error, we want to make sure that's less than or equal to 3 percentage points. And then from here, we can split this off into two different problems. So x minus 5 is less than or equal to 3, or x minus 65 is greater than negative 3, greater than or equal to negative 3. And then so when you solve that, you find your range of numbers. Doing the number line is probably a little bit easier. So that's it for 5.5 for learning target AV3. If you need to rewind any parts of the video, please feel free to do so. Otherwise, you do have some practice that you can do to get better at this concept.